Okay, so let's look at a first example of coding some structures and signatures, or right. So the first thing we're going to look at is a signature, aka an interface, aka an API. And so before we actually get to defining the signature, let me just write some client code down here, which we can use to kind of motivate what we're going to talk about. So let's just write a simple function to count the um, even numbers in L, which is a int list, and return an int. So, we've probably written this or something like it before. If the list is empty, then 0. Otherwise, if it's x times x's, if x is even, then something, or if it's false, then something else. So what if it's even? Then we want 1 plus count evens of x's, and if it's false, then we just want count evens of x's. There. Okay, so if I count the evens in 1, 2, 3, 4, 5, 6, 7, then I should get what? 2, 4, 6 is 3. Good. And then I write show evens, which takes L, which is an int list, and returns a string. And what that does is it does toString on count evens of L. And so if I show evens, then I get the string 3. Okay, so imagine that this program is our client code. Now, what this is doing is it's using ints to count the numbers. And so what I need here is that there's a 0 number here. What I need here is that I can increment the count. And what I need here is that I can turn the count into a string. And so if we want to change this program over to using an unknown implementation of a module instead of using int specifically, then the idea is we look at the operations we're doing on the counts here, and we define a signature that represents them. So I can have a signature for a counter equals the notation sig end. Okay, so the way to read this is I'm defining a new signature whose name is counter. Signature names by convention are in all caps, and then sig end is like the open paren, close paren, or open curly brace, close curly brace, or whatever of that, which says that the signature consists of the stuff between the sig and the end. And if I look at my code down there, the things that I have are a type of counters, and then a 0, which is a counter, and an increment function, which takes a counter to a counter, and then a show function, which takes a counter to a string. So the things someone would need to provide me to use this code is the 0, the increment, right? So like the 0 that I do right here, the +1 that I do right here, and then the toString that I do down here. And so we'll call those 0, increment, and show. Okay, to line up with the, yeah, good. Okay, so that's the signature. So this says that there is a type of counters. It has a 0, it has an increment, it has a show. So now the idea is that if I make a structure, let's call it int counter, colon counter, we'll fill that in a second, then I can edit the client code to refer to int counter dot 0 instead of 0. And I can change it to refer to int counter dot increment of the counter instead of 1 plus, and I can change it to int counter dot show instead of toString there, and I can say that what you're returning is an int counter dot counter. Okay, and the reason for that is that what does a counter package of code have in it? It has a type of counters, it has a 0, it has an increment, it has a show. Okay, and so the important point here is the client uses dot notation to refer to the pieces of a structure. So the structure int counter is going to have inside of it a type counter, a val 0, a val increment, a val show, right? So if I think about what the structure has to provide, it has to provide all of the stuff in the signature. And so the client code is now allowed to refer to those bits of that package of code by writing dot notation, which means you say first the name of the structure, int counter, and then you say the name of the thing inside the package of code, which is 0 or increment or show. Okay, so that's kind of modifying the client. So now, why would we do this, right? Like, why don't I just write the code that I had before? Well, the idea is we're going to be able to give two different implementations of int counter, two different implementations of the counter signature, sorry, of the signature, which behaves slightly differently. Okay, so let's give implementation number 1. So implementation number 1 in counter is going to just recover what we had written explicitly before. So counters are ints, zeros are zeros, increment, okay, so if the signature says that increment takes counters to counters, then it's supposed to be a function. And so we can put increment in as a fun declaration, even though the signature says vals. So when you say something in a signature, it's always either a type or a value, potentially a function type. Those values of function type can be implemented by fun declarations. And so similarly for show, we'll show the counter by int.toString. Okay, and so now if we did that, then hopefully if I do show evens, now I still get 3, and if I do count evens, I still get 3. All right, so now the big question is, why does this structure int counter meet this signature counter? Well, the general rule is that for a structure to match a signature, the structure must provide something for each thing in the signature. That is, if the signature says there's a type of counters, then the structure had better have a type of counters. If the signature has a 0, then it says there's a 0, the structure had better provide a 0. If the structure says there's an increment function, if the signature says there's an increment function, the structure had better provide an increment function, and so on. And the values provided must have the indicated types, right? So if I say 0 is counter, or let me do this one first. If I say show takes a counter and returns a string, the output of show had better be a string. But the implementation knows what the abstract types are. So in this chunk of code, I know that counter is really int, and that's because in this chunk of code where I'm implementing counters, I'm the one who's making counters exist after having chosen that counter will really be an int. In the next implementation we do, counter will be something different, but for this implementation, counter is really int, and so we know what that is. On the other hand, the idea is that down here, where the client doesn't know what that counter is really int, because down here, the idea is that like we modified our concrete implementation of count evens, which was using ints directly to go through this level of indirection where it uses counters. And so somehow like the point is that we're supposed to hide from the client that counters are really ints because, well, in a minute, we're going to change it to an implementation where they're not. So the point is now the same client code can work for different implementations where counters are ints or not ints. And the reason is that, well, all it's doing with a counter is it's using the 0, or it's using the increment, or it's using the um, show function, and those work no matter what implementation of counters I give you. Okay, so that's how that works here. And so just to go over some of the error messages, if you, for example, forgot the 0 bit there and you try to load things, then it'll say um, on 48 to 56, which is 48 to 56, this implementation, unmatched value specification 0. Okay, and so what that's saying is that there's no, hey, there's no 0 in this implementation, but the signature counter specifies that there should be a 0. And, on the other hand, if we had said like show of x equals x, then it would say value type in structure does not match signature specification. In particular, show was supposed to take a counter to a string, right? So it's reading that off from what's in the signature, but it actually takes a to a for any a, which isn't int to string. Okay, so if you violate these, that is the values provided don't have the indicated types, or you forget something that's in the signature, then it'll error. On the other hand, you're perfectly welcome to put more stuff in the structure that's not in the signature, which you think of as, in fact, a lot of code lives at this level. So that's code that's private to an implementation that you don't tell to the client. And the more code you can put private to the implementation, but not tell it to the client, the better. Because if you have stuff that's private to the implementation and not shown to the client, then you're free to change it however you want, and you don't have to touch any of the rest of the program. Instead, it's just a local change to this particular chunk of code. Okay, so that's the basic idea of an example of a signature, which is the interface between some implementation. So this here is the implementation, and the client, or the client code down here, uses the stuff that the implementation provides. And the next thing we're going to do is look at how we can change the client to use a different, better implementation of counters.